general trends in properties of B block elements. The third property is ionization potential. The fourth one is electronegativity. We already learned two properties. First one is general electronic configuration and oxidation state. The second one is metallic nature. The third one is ionization enthalpy or ionization potential. Fourth one is electronegativity. Now we go to study ionization enthalpy. We have already learned that as we move down a group, generally there is a steady decrease in ionization enthalpy of elements due to increase in their atomic radius. In B block elements, there are some minor deviations to this general trend. In group 13, from boron to aluminum, the ionization enthalpy decreases as expected, but from aluminum to thallium, there is only a marginal difference. This is due to the presence of inner D and F electrons, which has poor shielding effect compared to S and B electrons. As a result, the effective nuclear charge on the valence electrons increases. A similar trend is also observed in group 14. The remaining groups 15 to 18 follow the general trend. In these groups, the ionization enthalpy decreases as we move down from the group. Here, poor shielding effect of D and F electrons are overcome by the increasing shielding effect of the additional B electrons. The ionization enthalpy of element in successive groups is higher than the corresponding elements of the previous groups as expected. Go these P block elements. Here in the top, the ionization enthalpy, the first ionization enthalpy values are given. For boron is higher, aluminum is lesser. In gallium, it was 1 kilojoule per mole only increases. This is due to the inner D electron shielding. These two groups having the similar trend, except the others not having this trend. The general trend only followed. What is the general trend? From top to bottom of group, the ionization potential values decreases. For 15th group to 18th group, the general trend is followed. Here only a different trend, that is the shielding of inner D and F orbitals arises. Here, why this different trend is disappears? Here, the additional occupation of extra P electrons changes the different trend and follows the general trend. Okay, now go here and study ionization enthalpy. The remaining groups 15 to 18 follow the general trend. In these groups, the ionization enthalpy decreases as we move down the group. Here, poor shielding effect of D and F electrons are overcome by the increasing shielding effect of additional P electrons. The ionization enthalpy of electrons in successive groups is higher than the corresponding elements in the previous group as expected. Then electronegativity. As we move down the 13th group, the electronegativity first decreases from boron to aluminum and then marginally increases from gallium. Thereafter, there is no appreciable change. Similar trend is also observed in 14th group as well. In other groups, as we move down the group, the electronegativity decreases. This observed trend can be correlated with their atomic radius. See, the electronegativity value 2.04, here 1.61, here slightly increases. What is the reason? Similar trend also observed in group 14 as well. In other groups, as we move down the group, the electronegativity decreases. This observed trend can be correlated with their atomic radius. Atomic radius indirectly correlated with the shielding effect of d and f orbitals. Thanks for watching this video. Bye bye.